All right, 7th graders, in section 8.4, we're going to talk about graphing f of x equals a multiplied by the difference of x and h squared, and then plus k. So what are you going to learn about? Well, you're going to learn a couple of things, or actually a few things. You're going to learn, number one, how to identify even and odd functions. How are we going to graph quadratic functions that are in this form? And how are we going to graph quadratic functions that are in that same form, but with a plus k at the end? And then we're going to model real-life problems. Before I begin, let me first tell you this. You're going to have problems that look like this. F of x equals 2 multiplied by x minus 3 squared plus 1. You absolutely could FOIL or multiply the binomials x minus 3 and x minus 3. And then you could get, let's see, we would get x squared minus 6x plus 9 plus 1. You then could distribute the 2 and then add the 1, so that would be 2x squared minus 12x plus 18 plus 1 would be plus 19. You then would follow the rules which you already know, finding the vertex using negative b divided by 2a, and you would graph it like you have previously. You now are going to learn, how can I identify an even or an odd function? Well, here's how you do it. If I take the function y equals f of x, it is even that when you actually plug in a negative value, you get the original function of f of x for each x in the domain of f. The graph of an even function is symmetric about the y-axis. Now, a function y equals f of x is odd when you plug in f of negative x, and you're going to get a negative f of x function for each x in the domain of f. The graph of an odd function is symmetric about the origin. A graph is symmetric about the origin when it looks the same after reflections in the x-axis and then in the y-axis. What it means is this. If I have this function and I reflect it and you get that, that means it's been reflected across the y and then across the x, so it looks like this. The same thing is if you get and look like that, that means that it would be an odd function. A study tip would be this. The graph of an odd function looks the same after a 180-degree rotation about the origin. So it would look the same if you reflected it 180 degrees about the origin. Now, after the key idea, you're probably thinking to yourself, wow, this is kind of confusing. It's really not. So let's actually now just show you mathematically how you figure it out. We're going to start with A. Determine if the function f of x equals 2x is even or odd. So the first thing you do, here's your steps. You write the original function, f of x equals 2x. All we do now is substitute in negative x for where x is. All I do is just plug it in. And now, what is this going to give you? This is going to give you negative 2x. So we know that this right here is equal to negative f of x. Remember, f of x was 2x. But now I get negative 2x. So that's negative f of x. So if we look back up at our original, if you look at your key idea, it said this. If you had f of negative x equals negative f of x, which we do, all this change is the negative here, then you have an odd function. So this function is odd. So now let's look at part B. Part B, I write down the function. Step 2, substitute negative x in for all of the x values. So that would give me g of negative x equals, well, that's going to become positive x squared minus 2. Now you'll notice that means that g of negative x equals g of x. And the reason is because that's our original function. This right here is our original function, x squared minus 2, which it's the same thing. So g of negative x equals our original function. That means that this function is even. Now we look at our last example. We're going to plug in h of negative x. So that gives me h of negative x equals 2x squared, because that becomes positive, minus x minus 2. Well, did all of these values change? Did this change to a negative, this change to a negative, and this change to a positive? No, the only thing that changed was my middle term. Therefore, because we didn't get either one of these, let me write this down, and I put it up at the top. Because 2x squared plus x minus 2, that's the original, and negative h of x, which was this, where everything would change, you can conclude that they are not equal to each other. So this function is neither even nor odd. All right, now as we go over this, the minus h, before I even explain any of this number tells you to go right or left. And it's going to be opposite. So if h is greater than 0, so if h is positive, we are actually going to go to the right, but it actually looked like it's backwards. Because if I had x minus 2, that means I'm going to go to the right 2. If this was x minus 7, I would go to the right 7. And it's a horizontal translation, 8 units to the right, of ax squared. So if I just had ax squared, which is represented here in blue, let's look at this. If this did not move, so there's my vertex, which is the origin. If it was minus h squared, where h is greater than 0, it moves to the right, represented by the red parabola. If it's less than 0, which means it's negative, so you could have x plus 7, because you plugged in negative 7, that means I go to the left. So if h is less than 0, that's how many units, the absolute value, I go to the left. Now the vertex is always h0, and the axis of symmetry is h. But be careful. If I had something like this, the h is positive 3, because the negative is part of your formula. So that means your vertex would be right 3, and your axis of symmetry would be x equals 3. Example number 2. Graph the function g of x equals 1/2 multiplied by x minus 4 squared, and compare it to the original graph of f of x equals x squared. First thing I'm going to do is find my vertex. My vertex, well, there's h is 4, so my vertex is just 4, 0. My axis of symmetry is x equals 4. So now I'm going to start graphing it. So if I started by graphing my vertex at 4, 0, and my axis of symmetry, which is x equals 4, I now could pick any two values I want. So I'm going to pick two values that are less than the x coordinate of 4. So I'm going to plug in, well, we know 4 is at 0, so I'm going to plug in 3 and 2. Now, if I plug those in, 2 minus 4, that gives me negative 2, squared, which is 4, half of 4 is 2. That means if it's symmetric, 6 would also give me 2. If I plug in 3, 3 minus 1, that gives me negative 1 squared, which is 1, times a half, which is a half. So if I graph these, 2, 2, 3, half. So it's symmetric. So the other side, 5 is going to be half and 6 is going to be 2. So it's going to look like this. Now make a smooth graph. Obviously it's hard for me with my stylus on my iPad. But there's your graph. So what happens? How do you compare this to the x squared function? Now your x squared, you could have graphed if you would like. There's your x squared function. We could write this as your answer by comparing it. Both graphs open up. The graph of g, which is ours, is wider than the graph of f, which was the parent function. The axis of symmetry, which is x equals 4, and the vertex is 4, 0, which means that's been shifted 4 units to the right. So the graph of g is a translation 4 units right, and a vertical shrink. I will also accept a horizontal stretch by a factor of 1/2 of the graph of f. So this last statement is the most important. All right, so the next thing that we're going to do is add in this plus k. This plus k is going to tell you whether your graph is going to go up or down. Up or down. So the blue is your parent function. If it's plus k, that means you're going to go horizontal. I'm sorry, that's not what you're going to do. If it's plus k, that means you're going to go up k. If it's minus k, that's how many you go down. So looking at both the h and the k together, the h, this is probably the important part to get out of this. The h tells you to go to the right. The k tells you to go up or down. So the h, if positive, goes to the right. If negative, goes to the left. And then k tells you to go up or down. Your vertex is this, h, k. But notice right here that the minus is part of your function, your formula. So if it's minus 5, that means the h is just 5, not negative 5. So if you had this, 3 times x minus 2 squared minus 7. Your h is 2, your k is negative 7, which means your vertex would be 2, negative 7. So if I'm graphing y equals a multiplied by x minus h squared plus k, you're going to graph g of h, here it is. Compare it to your original one. Step 1, we graph the vertex. Your vertex, well, that means h is negative 2. So the vertex is negative 2, 3. So if I graph my vertex, negative 2, 3, that means my axis of symmetry is x equals negative 2. All right, so now I'm going to pick two values. I'm going to pick my easy values. So I'm going to pick, let's see, we know negative 2 is 0. So I'm going to pick negative 1 and 0. So negative 1. Negative 1 plus 2 is 1. 1 squared is 1. Times negative 2 is negative 2 plus 3 is 1. So that means negative 3 should also be 1. If I plug in 0, that gives me 2 squared, which is 4, times negative 2, which is negative 8, plus 3, which is negative 5. So that means both of these are going to be negative 5. If I graph them, negative 1, 1, negative, I'm sorry, that was not negative 2, 0 here. That is my fault. This should be negative 2, 3 is the vertex. And so negative 3, 1, negative 4, negative 5, and 0, negative 5. And once again, your graph would look much better than mine did. So what do we know? Well, the graph G, which is the blue, opens down and is narrower than the graph of F. The vertex is negative 2, 3. That means it's been shifted 2 units left, 3 units up. So the graph is a vertical stretch by a factor of 2, a reflection in the x-axis because it's been reflected, and then it's been moved 2 units left, 3 units up. So the next example says, let's take the example we just had in example 3, and now I want you to graph this. All you do is it says x plus 5. That means your graph will just shift left. That's it. So we take the graph we just drew, which is the blue or the black one, plus 5. That means your h is negative 5. It shifts 5 units left. That's all that means. So we take our graph, and then blue line is the graph of our function where we shift it 5 to the left. Now, there are many fountains that you've seen maybe in shopping malls or hotels that have the form of a parabola. So how are we going to model this? How are we going to do this problem? Well, here it is. Water fountains are usually designed to give a specific visual effect. For example, the water fountain shown consists of streams of water that are shaped like parabolas. Notice how the streams are designed to land on underwater spotlights. Write a quadratic function that models the path of the stream of water with a maximum height of 5 feet, represented by a vertex of 3, 5, landing on a spotlight 6 feet from the water jet, represented by 6, 0. Well, what do I know? I know that this is going to be over 3, up 5. That's my vertex. The water jet is at 6, 0. Which means 1, 2, 3, 1, 2, 3. It's going to be symmetric. So I have to draw or write an equation that represents that. Well, the first thing I'm going to do is write down my formula. A times x minus h squared plus k. Well, step 1 is plugging it in. That's all I need. Now, I don't know A, but I do know H. H is the vertex, which is 3. I know K. K is how far up it goes. So the vertex goes up 5. So now, what do? Well, I know this is my value of x. X is 6 in this ordered pair, so I take the 6 and plug it in right here. So I'm going to get, and then 0. 0 is going to go over here, where f of x is, because that's y. So my equation is going to be 0 equals a multiplied by 6 minus 3 squared plus 5. And now I just solve for a. So 0 equals 6 minus 3 is 3 squared is 9a plus 5 equals 0. I subtract 5. I divide by 9. My a value is negative 5/9. So I plug that into my formula. F of x equals negative 5/9 multiplied by x minus 3 squared plus 5 would be the equation that would represent the path of the stream of water. Now, once again, you just graph that, which we kind of did here. So there it is. You would have to put x and y, but notice I don't have arrows at the end. The reason I don't is because the water does not continue once it hits x-intercept of 0.